For these two quadrilaterals, I can see that I'm working with trapezoids because I can see that I have exactly one pair of parallel sides. The little triangles or the little arrows tell me that those are my bases, which are parallel. So both of these figures are just going to be trapezoids. Now there's not much we know about trapezoids as far as properties go. In fact, the only property we're really going to use to help find missing angles is that we have angles that are on the same leg, meaning the two non-parallel sides, angles on the same leg, are going to be supplementary, meaning they'll add up to 180. That's the only real property we have for working with trapezoids. So these two angles are on the same leg of my trapezoid. So since those two angles have to be supplementary, I'm going to do 180 minus 95, leaving me with an angle of 85 degrees. And I'll do the same with the other leg. So there's the other leg, the non-parallel side. So those two angles also have to be supplementary. If I subtract from 180, I'm left with an angle of 60 degrees. And if I wanted to check it, I could add up all four angles. They'd have to add up to 360. On my second trapezoid, just be careful that you realize your legs this time are not the vertical sides. The bases actually go vertical, so if it helps, turn your paper. So these two angles need to be supplementary in this case. Those are two angles that are on the same leg of the trapezoid. So since those need to add up to 180, obviously this other one would also need to be 90 degrees right there. So we have another right angle. And then those two angles are also going to be on the same leg and supplementary. So if I subtract 45 from 180, I'm left with an angle up here of 135 degrees. I'm asked to classify this figure in the keystone of the arch. I can see that it's going to be a trapezoid because I can see that I have one pair of parallel sides. I know that not because it looks like they're parallel, but because I see that little triangle, which makes them parallel. But in addition to just being a trapezoid, I have one more specific name I can give it. I'm noticing that the two legs are the same length. The two legs are congruent, meaning this is in fact going to be an isosceles trapezoid, an isotrap as I call it. So I have an isosceles trapezoid. That's a trapezoid that has the two legs congruent. So now that I know what it is, let's find the measure of all the angles. Well, because it's a trapezoid, it's in the trapezoid family, that property we just used still works. So those two angles that are on the same legs still need to add up to 180 degrees. So angle M needs to be 95 degrees. Okay? The other two angles on the other leg are not given to us, but because we have an isosceles trapezoid, there's one more property I know. Specifically for an isosceles trapezoid, I know that base angles are congruent. Base angles are angles that are on the same base. I know, tricky vocab word right there. And they're the same thing. So these two angles up here are on the same base of the trapezoid, meaning they're both going to be congruent. So angle K is going to be 85 degrees. Because again, we have an isosceles trapezoid specifically, those two base angles are also going to be equal. So angle J is also going to be 95 degrees. And last up, let's classify one more quadrilateral. I know right away that this is going to be a trapezoid, and not because it looks like a trapezoid, but because I see one pair of parallel sides. And then I don't know if the legs are congruent to each other or not, based on the diagram. They haven't told me that. So I can't just call it an isosceles trapezoid, but they did give me some angles to work with. So let's maybe find the other angles out and see if we can give this trapezoid a more specific name. So I know because it's a trapezoid that those two angles have to be supplementary. That's true of a trapezoid, or an isosceles trapezoid. So angle F has to be 70 degrees to make those supplementary. And for a similar reason, angle H has to be 110 to make these two angles supplementary. Well, if we look at what we have now, I've got base angles that match up. Those base angles are both 110. Those base angles are both 70. Well, that's going to make this not just a trapezoid, but an isosceles trapezoid, because that was one of our properties. So I can say that this figure is in fact an isosceles trapezoid. And now that I know that, now I do know my legs are congruent, because I know that all my properties are going to be true once I've proven that this is an isosceles trapezoid.